Hello everyone, I am Kawser Bepary and our task is to find the electromagnetic leakage model in different pre-silicon stages and develop proper metrics to evaluate side channel leakage vulnerability quantitatively and validate the results with post-silicon assessment results. So initially we went through the feasibility of leakage modeling in different abstraction levels. So in RTL, we have the least amount of information available. In gate level, we may find the number of fan-outs and some other additional information. In layout level, we have lots of information available and we can perform spice level simulation, but it is very time consuming to perform that in layout level. And in RTL level, the accuracy of the modeling may be very low. So we choose gate level netlist for our initial assessment framework. So in this framework, we start with the RTL code and synthesize to get a flattened gate level netlist. So from the netlist, we extract the number of resistors and fan-outs and use a leakage model to compute the simulated EM traces. So we use a set of semi-fixed plain text and a set of random plain text and perform functional simulation to find the traces. And the vulnerability metric here we use our well-test t-test, and the leakage is computed from a weighted Hamming distance model, which includes the switching activity and fan out of each of the resistors. Now, a well-test t-test can suggest whether an observable difference between two samples is large enough to say that the design is leaky, or the electromagnetic traces are correlated with their input plain text. So here we see an example of two different leakages, and we can actually identify each of the round operation in the leakage traces. So the p-value threshold is typically considered as 4.5, which corresponds to 99.999% confidence to say that the design is leaky. So in this example design, we say that as the number of traces increase, we see that the leakage for some of the time stamps increases. As you can see here, for some of the time samples, we find leakage traces very high, and for other, it's not so much. So in the stability test, it can only find a pass or fail value of whether the design is leaky or not. So in order to find a quantitative analysis of that, we are also considering a KL divergence test, which can say how much leaky a design may be for in a certain clock cycle and for a certain submodule. So this was our initial framework for EM side channel assessment in gate level. Thank you, everyone. If you have any questions, please feel free to contact us.